Welcome to Tami's Max, 11th standard NCERT, it's permutation combination. So in the previous video, I was discussing with you a very simple thing. I was talking about tools and then I was talking about the factorials. Today, let's discuss symbols like what is NCR, what is 7C2, what is 10C2, what is a permutation, what's a combination. Well, let's discuss all those things before we could start actual problems from our NCERT book. Now, let's see that we have n different things. Make a note of that. N different things. The symbol NCR. The symbol NCR stands for. There are n different things and I choose R in that. I only choose. It's a combination. I choose R in that. I buy an apple, I buy an orange. I buy an orange, I buy an apple. It's same. So when I interchange and talk, it doesn't give you different cases. It's the same case. That is a combination. This NCR, there are n different things and I choose R from that. What are the conditions here? R can't be negative, R can't be fraction, n can't be negative, n can't be fraction, and R cannot exceed n. R can be 0, R can be 1, R can be 2, and R can be up to n. R can't be n plus 1, R can't be minus 1. Those things cannot happen. The value of this will be factorial n by factorial n minus r factorial r. This is the value of that. Fine. Now, what will be the value of 8C2? Out of n different things, I choose 2 in that. N different. This is factorial 8. N is 8 by n minus r. 8 minus 2. 8 minus 2, factorial 6, factorial r, factorial 2. So this is factorial 8, factorial 6, factorial 2. That is the answer for this. This is one way to write. The next way to write will be factorial 8 can be written as factorial 6, 7 into 8 by 1 into 2. And this factorial 6, this will get cancelled. So 8C2 if I have 2 here. Start with 8. Reduce it by 1. 7 by 1 into 2. So this will be the answer. So when I have 8C2, of course you can write like this. If you are going to write like this, all this you will cancel and you will calculate. But the easiest way will be start with 8. And 2 here, no? So only 2 terms should be in the numerator. 8, lessen it by 1, 8 into 7 by 1 into 2. Now what will be the value of what will be the value of 8C6? This is factorial 8, 8 minus 6, factorial 6. What is 8C2? Factorial 8, 8 minus 2, factorial 2. Right? Both are same. So 8C6 is same as 8C2. How does it happen? Choosing 2 is neglecting 6. Out of 8 different things, choosing 2 is neglecting 6. What will be 10C9? It will be same as 10C1. Choosing 9 is neglecting 1. Out of 10 different things, choosing 9 is neglecting 1. So 10C9 will be 10C1. Fine. What will be 7C5? It will be same as 7C2. Correct. So this is regarding how to find out the value of NCR. Next, what is permutation. Suppose in a cardboard, I have the number 1 and 2. I arrange it like this. I arrange it like this. It's not the same. That will be 12 and this will be 21. How can it be same? It's not same. So when I interchange, I get a different case. That will be a permutation. Now, how will you permute NPR? How will you permute R things out of N different things? How will you permute R things out of N different things? Now, permuting R things out of N different things is as good as I have R boxes. I have R boxes. And I have N different things with me. The number of ways I can fill up these boxes is equivalent to. The number of ways I can fill up these boxes is equivalent to NPR, where things are not repeated. I can't repeat it. N different things. One thing could come only in one box. You can't put the same thing in another box. Take the first box. Any one thing you can put in that, so it can be filled in N ways. Take the next. You can fill it in N-1 ways because already 1 has gone into this box. Come over here. This is N-2. Now come for the last. Second is N-1. Third is N-2. So Rth will be N-R-1. I hope you understand. This is N-2 minus 1. This is N-3 minus 1. Third box. This is Rth box. So N minus R minus 1. So now this will be N minus 1, N minus 2, N minus R plus 1. So this will be the number of ways I can permute R things out of N different things. Now I want a pattern to remember this. I'll start from 1 here. This is N minus R. Now, count from there. Continuous till N you have now. 1, 2, 3, N minus R plus 1. So, multiply down also by that. N minus R. So, numerator is factorial N. Denominator is factorial N minus R. This will be the number of permutations you can have out of N different things where the permutation is done with R things. Now next one will be how will you permute 2 things out of 5 different things? What's the formula? Factorial 5 by 5 minus 2 factorial 3. Factorial 5 can be written as factorial 3, 4 into 5 by factorial 3. This gets cancelled. 4 into 5. So what's the short way to write 5p2? Start with 5. Reduce it by 1. That's all. Down won't come. In NCR, there will be a down. Like 5c2. 5 into 4 by 1 into 2. But that won't be there. So which is more in number, permutation or combination? It is obviously permutation is more in number than combination. Okay. Next is, in how many ways can I permute 5 things among themselves? What do I mean by that? In how many ways can I arrange 5 things among themselves? 5p5. 5p5. 5 things are arranged among themselves. I permute it among themselves. First box can be filled in 5 ways. Next box in 4 ways. Next box in 3 ways. Next box in 2 ways. Next box in 1 way. It is factorial 5. So 1 into 2 into 3 into 4 into 5, factorial 5. Now wait for a few minutes. I will tell you why you multiply and all that. So 5p5 will be factorial 5. What will be 6p6? Will be factorial 6. What will be npn? Will be factorial n. And things can be arranged among themselves in factorial n ways. Okay, okay. Now, let's talk about what is mutually exclusive cases and what is independent cases. A little explanation I will give. You keep it with you. Whenever I want to make use of it, I will use it. What is mutually exclusive cases? Like, take your own self. You're sitting in front of the video and listening to permutation combination. Or you're in a hotel having your dinner with your parents. Or you have gone to a cinema theatre where you're seeing a cinema. Or you're chatting with your friend. Don't please tell me I'm doing all this with the mobile in my hand. I'm listening to this also. No, these are not counted like that. So when you do one action, you can't do the others. When you're listening to my video, you're not in the cinema theatre. When you're in the cinema theatre, you're not with your parents in a hotel having your dinner or your lunch. So you are capable of many things. You're capable of so many things. But when one thing happens, the rest is ruled out. That is mutually exclusive. This or that. I'm either listening to the video or in a proper way. This is mutually exclusive. What are independent cases? I'm speaking in my home, teaching you permutation combination. You're listening to me from your home. It is happening at a time. One cannot prevent the other. All happens at a time. This and that happens. That will be independent. Okay. So now this small, I'm giving you very simple way to understand what is mutually exclusive and what is independent. Now, let's have a simple question and let's have the answer to that also. Now, this is your home and this is your school. In between, you have a tea shop. Now, morning, you leave your home. There are 3 ways you can go to the tea shop. There are 3 routes you can take to go to the tea shop. And from the tea shop, there are 2 routes you go to school. In how many ways can you leave your home, go to the tea shop, have a tea, and then go to school? In how many ways can you do it? Anybody? Is it 5? Any one of you saying 5? No, 5 is not correct. Then which is correct? Corresponding to every one here, you will have 2. But there are 3 here. So there will be 3 into 2. That will be 6. This and this happens. So you multiply. If one action happens in P ways, another action happens in Q ways, another action happens in R ways, all together will happen in P into Q into R ways. Like that, you have many things which can happen. For example, I have school, and from school I go to tea shop. I write the other way around. And from tea shop I go home, and after going home I go to my friend's house. I go to my friend's home. From school to tea shop, 3 ways. From tea shop to home, 2 ways. Or 3 ways, 4 ways. And from home to friends, another 4 ways. In how many ways can I go from school to tea shop to my home, and from my home to friend's house? In how many ways can I do it? This is 3 into 1, 2, 3, 4 into 1, 2, 3, 4. I hope you understand this. Okay? So revise this and come. I will start problems from our NCERT book in our next video.